To the series of videos where we solve the questions in the 2026 BECE Maths Paper 1. Question 21. Kofi had 150 birds. He sold 26 of them and kept the rest equally in 4 cages. How many birds were kept in each cage? So we are told that Kofi had 150 birds. He sold 26 of them, and then the rest were kept equally in 4 cages. So let's start with the 150 we are given. He sold 26 of them. So after selling the 26 birds, how many birds did Kofi have left? We have to subtract the 26 from the 150. When we do that, we get 124. So it was these 124 birds that Kofi kept in 4 cages. Let's draw boxes for the cages. So you want to now arrange or distribute 124 birds into 4 cages. And the question is, how many birds are going to be in each cage? And the answer is 124 divided by 4. And what do we get when we divide 124 by 4? We get 31. So our answer is C. Question 22. Here we are given that the ratio of x plus 2 to x minus 2 is equal to 1:2. And we are supposed to find the value of x. So one way to write this expression, x plus 2 is to x minus 2 is equal to 1:2, is to write them as fractions. So the ratio x plus 2 is to x minus 2 can be written as x plus 2 over x minus 2. And now this ratio is equal to 1/2. So how do we solve for x? We can cross multiply. When we do that, we get 2 times x plus 2 equals 1 times x minus 2. So we expand the brackets. 2 times x plus 2 is 2x plus 4. And this is equal to x minus 2. So we group like terms. We get 2x minus x is equal to minus 2 minus 4. 2x minus x is x. Minus 2 minus 4 is minus 6. So that gives us x as minus 6. Therefore, our answer is B. Question 23. Given that mu is equal to the set 1, 2, 3 up to 10, and m is equal to the set 2, 3, 5, 7, where m is a subset of mu, list the members in mu that are not in M. So we are given mu 1, 2, 3, all the way up to 10. So let me just write it since there are not so many. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we are given the set M, which is 2, 3, 5, 7. And we are supposed to list the members in mu that are not in M. So let's cancel out those members that are in M. And the first one is 2. So we cancel out 2. The next one is 3. Cancel out 3. The next is 5. Cancel it out. The next is 7. So after canceling out, we are left with 1, 4, 6, 8, 9, 10. And D is the one that has that collection. The next is question 24. Question 24 says, if 2 to the power 2m is equal to 8, find the value of m. So 2 is raised to a power that is 2m, and this whole expression is equal to 8. and we're supposed to find the value of m. So solving an exponential equation or indicial equation like this, we want to write both sides in the same base. So having the base here being 2, would like the base on the right to also be 2. So what power of 2 is 8? That's the real question. And if we know that 2 to the power 3 is equal to 8, then we can go ahead. What this means is that 2 times 2 times 2 is equal to 8. So using that fact, we can now come and write here 2 to the power 2m equals 2 to the power 3. And now that we have the same base on the left as on the right, we can equate the exponents. So now 2m is equal to 3. And if we write that 2m is equal to 3, then m is equal to 3 over 2. And what is 3 over 2 equal to? Well, 3 over 2 is equal to 1 and half. And looking at the answers here, they want us to write it as a decimal. Half is the same as 0.5. So 1 and half is the same as 1.5. So that gives us the answer C. Question 25. A boy spends 1/4 of his pocket money on books and 1/3 on pens. What fraction remains? So the boy has his pocket money. One whole number represents all the pocket money that he has. That's the entirety of the thing. So here we can think in terms of a full shape like a circle. If this is all his pocket money, then we can start dividing. Imagine we are just dividing. This is something, this is another thing, this is something. So the full circle represents the whole. We can also use a square. It can be any shape that we then begin to divide. So maybe this portion is used for something, and then this portion also used for something. But the point I want us to note is that his full pocket money is represented by the number 1 whole. So now if he's spending 1/4 on something, 1/4 is spent on books, and then 1/3 on pens. What fraction remains? The fraction that's going to remain is that 1 whole minus the 1/4 that he spent on books, and then also minus the 1/3 that he spent on pens. So we are supposed to calculate this fraction. And what is it equal to? Well, we can write them over the same denominator. So if we do that, we can try to write over a common factor. There's 4 here, there's 3. It's convenient to just use the product. So here it's 4 times 3, 12. You can also use the LCM, which happens to be 12 in this case, but often it's just easier to just multiply and get the product. So using a common denominator of 12, if we write one whole number, we get 12. So 12 over 12 is equal to 1. Then what do we have for 1/4? Well, 4 divides 12 to give 3. So we multiply that 3 by the 1, and then we get that. So 3 over 12 is equal to 1 over 4. And then 3 divides 12 to give 4. So we multiply the 4 by the 1, and then we get 4. So 4 over 12 is equal to 1 over 3. So you have this 12 minus 3 minus 4 all over 12. 12 minus 3 minus 4 is 5. So 5 over 12. And that is B. Question 26. Two sets which have the same number of members are dash sets. So if two sets have the same number of members, what kind of sets are they? Well, let's go through the options one after the other. When do we say two sets are equal? Two sets are equal if they have the same elements or the same members. So if you have the set 1, 2, 3, is the same as the set 2, 1, 3. In a set, it doesn't matter the order in which you put the elements. So equal sets are set that have the same elements. Of course, if they have the same elements, then they're also going to have the same number of elements. But the important thing about equal sets is that they have exactly the same members. So this set is equal to this set, but it's not equal to the set, let's say 1, 2, 4. 1, 2, 3 is not the same as 1, 2, 4, of course, because this 4 is different from this 3. So they all have the same number of members, but they are not equal. Intersecting sets are sets that have elements in common. For instance, the set 1, 2, 3 and the set 3, 4, 5. These two sets are intersecting sets because they have the element 3 in common. There's 3 here, there's 3. So they have an intersection. Normally when we draw a Venn diagram, if you draw this for the set 1, 2, 3, you're going to have maybe 1, 2, and 3 is in the intersection. Here you also have 3, 4, 5. So this represents the set 3, 4, 5, and this represents the set 1, 2, 3, and their intersection is the 3. Equivalent sets, that is what we're looking for. Equivalent sets are sets that have the same number of members or the same number of elements. So a set like 1, 2, 3, it has 3 elements, and a set 1, 2, 4 also has 3 elements. So these two sets are equivalent. They are not equal, but they are equivalent. So the set, let me just give another example, 7, 5. This set has 2 elements, so it's equivalent to the set 1, 2, because all you care about is how many elements there are. Let's look at the fourth option, a union. The union of two sets is just the elements that are in, if you like, what we get when we put the elements in all of the sets together. If it's two sets, then what we get when we put the elements in the two sets together. So the union of 7, 5 and 1, 2 is just 7, 5, 1, 2, the set that contains all the elements. So our answer is C. Question 27. Change 25% to a fraction in its lowest form. So we have to first write 25% as a fraction. 25% is equal to 25 over 100. Now, after writing it in this form, we want to write it in its lowest form. So we try to see, can we divide 25 by something and divide 100 by the same thing? And the answer is yes. We can divide both of them by 25. So 25 divides that, we get 1. 25 divides that, we get 4. So this fraction is equal to 1 over 4. And once we get 1 over 4, we cannot reduce it further because we have a 1 here, and we need an integer. So that's the answer, 1 over 4. Question 28. So here we have a mapping where the numbers in the top row are mapped to the numbers in the bottom row. So x goes to y, 1 goes to 3, 2 goes to 6, 3 goes to 9, and so on. And the question is, what is the rule for the mapping? Well, here we have to watch carefully and see what is going on. What do we do to the numbers at the top to get the numbers at the bottom? And I hope you've seen that we multiply the numbers at the top to get the numbers at the bottom. So when you multiply x by 3, you get y. When you multiply 1 by 3, you get 3. When you multiply 2 by 3, you get 6. When you multiply 3 by 3, you get 9. 4 by 3, 12, 5 by 3, 15. So our answer is A. Question 29. Find the circumference of a circle whose area is 100 pi centimeters squared. So we have a circle, and we know the area of the circle. So the area that is covered by the circle is 100 pi centimeters squared. Now we have to remember the formula for the area of a circle. For a circle, the area is pi r squared. So we have to set this area to this quantity. So pi r squared is equal to 100 pi centimeters squared. And so we want to find r, because when we find r, we can use it to find the circumference of the circle. Remember that the circumference is given by, let me call this circ, is given by 2 pi r. So because the circumference is 2 pi r, if we find r, we know we can find the circumference. So let's try to find r over here. So we can divide both sides by pi. There's pi here. There's pi here. So if you divide both sides by pi, you just cancel out the pi. So we are left with r squared is equal to 100 centimeters squared. So we take square root of both sides because we have r squared, and we want r to stand alone. So if we take the square root of r squared, we get r. And when we take the square root of 100 centimeters squared, what do we get? Well, 10 times 10 is equal to 100. So the square root of that quantity is just 10 centimeters. So the centimeters times centimeters also gives us centimeters squared. So the square root of 100 centimeters squared is 10 centimeters. So we can now use that r to find the circumference. So using this formula, we have that the circumference is equal to 2 pi, and our r is 10 centimeters. So this is equal to, well, 2 times 10 is 20, so 20 pi centimeters. And looking at the answer options, that is D. Question 30. So here we have a figure that is not drawn to scale. That means that you cannot use your protractor to just measure things to get the answer. So we have two parallel lines. This line and this line are parallel to each other. And we have this triangle also, this triangle. So we want to find y. And how do we do it? Well, we have a hint here. These two marks on the triangle show that the two sides of the triangle are equal. That means that this angle is equal to this angle. And then we also have to notice, because these two lines are parallel to each other, this angle, 56 degrees, is equal to this angle. So we can write 56 degrees here. This angle is 56 degrees. And because it's equal to this angle is also 56 degrees. So now we have a triangle in which one of the angles is 56, the other one is 56, and the third one is 2y. So we use the fact that in a triangle, the angles add up to 180. So let's write that. We have 2y plus 56 degrees plus 56 degrees. And this is equal to 180 degrees because these three are angles in a triangle. So we add them up, see what we get. 56 plus 56 is 112. So we have 2y plus 112 degrees equals 180 degrees. So now we subtract 112 from both sides. When we do that, we get 2y is equal to 180 minus 112. What does that give us? That gives us 68. So let me just write the full thing. 180 minus 112. So we now have 2y equals, this is 68 degrees. So if we have 2y equals 68 degrees, then what is y? Well, y equals 68 over 2, which is 34. So y is 34 degrees. So our answer is C. All right. That brings us to the end of this portion of going through the questions, but you can visit our website, preppyonline.org. You're going to find the full set of questions and the full set of solutions. You can download them and keep revising.